Hello everyone. Today's topic is cancellation law for fractions, but I want to quickly review over some simple things. So let's see what I have here for you. I have the number line. I've only marked off 0 and 1, and clearly this point 1 can also be written as a fraction. Do you see why? Let's see. This unit segment is cut up into, as we see it, exactly one piece. It's intact. That means in our fraction symbol, we can write it as a whole number over a whole number. The denominator 1 is telling us, here's the unit segment intact. Intact, so it's cut up into one piece. This numerator 1 is telling us it's one copy. So always remember this. 1 over 1 is exactly the same point on the number line as 1. If you remember that, then these are easier to remember. 2 over 1 is exactly 2. 2 over 1 can be thought of as 2 copies of 1 over 1, or 2 copies of 1, and that means 1 plus 1, which is 2. So if you can remember this picture, that helps us see why 1 over 1 equals 1, then you're good to go. Then you can say 2 over 1 equals 2, and now that we are getting familiar with using symbols, we can write n over 1 equals n, but remember we have to always say what this letter n means. So that's why I write, in general, for any whole number n, we have n over 1 equals n. So that's a quick review. I have a few more things to quickly review, and then we will move on to the cancellation law. So here's a very quick review of concepts that you already know quite well. Two fractions, remember, are said to be equivalent if they are the same point on the number line. And FFEF is something you're now very familiar with. We'll read through it again. A fraction is unchanged when its numerator and its denominator are both multiplied by the same non-zero whole number. So that means if you start out with a fraction and you choose to multiply the numerator and denominator by the same non-zero whole number, you don't really get a new fraction. That fraction and the first fraction are equal or equivalent because they would be the same point on the number line. Now let's go here and look at FFEF written using symbols. Here's FFEF using symbols. A fraction a over b is exactly equal to this fraction where all I've done is in the numerator I've multiplied it by n, and in the denominator too by n. You're familiar with this notation. And notice I've carefully written out what those letters are. A, B, N are whole numbers, and the denominators, do not want them to be 0, and that's what I'm specifying here. Now you guys have done a lot of examples, a lot of work with FFEF, and what you did was you took a fraction such as 2/3 and you created an equivalent fraction using FFEF. And perhaps what you did was something like this: 2 over 3, and then you multiply numerator and denominator by 7. And then you said 2 times 7 is 14, 3 times 7 is 21, and you concluded 2/3 and 14 over 21 are equal fractions, or they're equivalent fractions. 2/3 and 14 over 21 are the same point on the number line. That's how you used FFEF. So now I want to ask you to look at FFEF from a slightly different perspective. So look at what I have here. 2 times 7 over 3 times 7. You see that out here, 2 times 7 over 3 times 7. So earlier what you were doing was you were using FFEF and you were multiplying out these and saying 2 times 7 over 3 times 7 is 14 over 21. That's how you created your new fraction 14 over 21. What happens if you look at 2 times 7 over 3 times 7 and think to yourself, this is exactly same as 2/3. So in other words, I want to be able to look at this expression and also go in this direction and say this is same as 2 over 3. You're very familiar with multiplying these guys and going in this direction and thinking to yourself, 2 times 7 over 3 times 7 is 14 over 21. But this one really needs a little more thought, a little different way of thinking, a slightly different mindset, where anytime you see 2 times 7, you probably have a tendency to multiply it out. It's that you probably think that sign is urging you to multiply. And yet, I'm asking you to have a slightly different mindset. Think of it as, well, from here, you definitely know 2 times 7 over 3 times 7 is 2/3. So how do we go from here to here? What can we say to ourselves that says don't multiply? You see a multiplication sign, but don't multiply out. Here's what mathematicians say. We have a law called Cancellation Law. I'll state it. It's really fundamental fact about equivalent fractions, written in such a way that it puts you in the exact mindset to go from here to here. What we do is we recognize 7 as a common factor of the numerator and denominator. And we say we can cancel out the common factor. If you want, you can strike a line like this and cancel it out. Remember, you can only cancel it out like that when you see a multiplication expression. In other words, 2 times 7 is indicating to you 7 is a factor. And 3 times 7 is indicating to you 7 is a factor of the denominator. 7 is a factor of the numerator, 7 is a factor of the denominator, and cancellation law tells us we can cancel it. Like I said, cancellation law is just FFEF repackaged. In other words, instead of going from here to this, we are now saying this is also same as this, and I'm giving you some math vocabulary to justify how to go from here to here. Applying the cancellation law, we get 2/3. So that's one demonstration. Now let's look at this guy. It looks very much like this. Right away, I hope you're noticing here 4 times 6. I hope you're noticing 6 is a factor of the numerator. That's what it is. Here, 6, that we have a 6. And if you really need to see it this way, you can also think of 4 times 6 over, you can think of 6 as 1 times 6. I write this so you can see 6 is in fact a factor of the denominator. So now look at this. 4 times 6 tells you 6 is a factor of the numerator. 1 times 6 tells you 6 is a factor of the denominator. Now what? If I'm telling you do not multiply 4 times 6 and say 24, and 1 times 6 and say 6 and write 24 over 6. That would be correct, but that's not a direction I want you to take. Instead, I want you to be in your new mindset and be willing to cancel 6's and write this as 4 over 1. Now you know 4 over 1 is also same as 4. Let's look at number 3 here. 116 times 397 or 116. I hope you kind of stopped yourself from saying, oh, I need to multiply these guys out because there's a multiplication sign. Look at this whole problem carefully, all of it at once. Then you will see 116 is in the numerator, 116 is in the denominator. If you wish, you can write this as 116 times 397 over 1 times 116. If you wish, you can do that, but you can include this 1 times, but when you do more problems, you won't need to do that. And now you can really see 116 is a factor of the numerator, 116 is a factor of the denominator. We can cancel it out, put a line if you want or not, and then all you'll be left is 397 over 1, which we can write as 397. Now let's look at number 4, 35 over 25. It is not written as the problems 1, 2, 3. Here, I want you to think to yourself, looking at 35 and 25, do you see a relationship between those two numbers? I picked easy ones so you can think of them as coming up in the multiplication table of 5. In other words, I want you to right away recognize, oh, 35 and 25 are both multiples of 5. In other words, by now you're probably thinking to yourself, oh, she means 35 is 5 times 7. 25 is 5 times 5. Now, with that new mindset where I say anytime you see this expression, you go in this manner. Now that you see this expression, I hope you can go in the other direction where you recognize 5 is a common factor of the numerator, 5 is a common factor of the denominator. I may cancel out the common factor by cancellation law, which I'll state in a minute, but it's really FFEF in the other direction. And then recognize it as 7 over 5. So that means what we are saying from all of these examples is 35 over 25 is exactly same fraction as 7 over 5. 4 times 6 over 6 is exactly same as 4. And so on. So we are ready to summarize of the wisdom of the examples we have done. So let's see what we have up here. Suppose a, b, n are whole numbers with b not equal to 0 and n not equal to 0. You're very familiar with FFEF, where we have the fraction a over b, and we said that's exactly same as n times a over n times b. Now, the examples there tell us that we have been going from this kind of an expression to this expression, which is what I have packaged in here. All I have here is n times a, n times b written here, equals n a over b. And I'm calling this the cancellation law. From the way I have written, you can see FFEF is the cancellation law. Cancellation law is FFEF. We're just giving it a name so that it feels much more natural to go from this kind of an expression to this expression, where we can say I'm cancelling out the two factors to get a over b, instead of saying I'm using FFEF in the other direction. That kind of doesn't feel as natural. So that's the only reason I'm now introducing cancellation law. It's not a new concept. It is really FFEF, just packaged slightly differently in a usable way, in a way you can talk about it. Let's now apply the cancellation law to reduce a given fraction to its lowest terms. What this means is as follows. Here we see a fraction 6 over 9. So this is a point on the number line. It's telling us it's 6 copies of 1/9. Perhaps when you look at 6 and 9, there is a whole number that's coming to your mind. In other words, you're able to see 6 as 3 times 2 and 3 as 3 times 3. So when we rewrite 6 as 3 times 2, 9 as 3 times 3, do you now see that we are ready to apply the cancellation law, and what we get is 2 over 3. So you can see this fraction 2/3 is exactly same as the fraction 6/9. 2 copies of a third are exactly same as 6 copies of 1/9. 2/3 and 6/9 are the same point on the number line. Technically speaking, 2/3 is just as good as a name as 6/9. 6/9 is just as good as the name 2/3 for that one point on the number line that you're thinking about. They're both perfectly good. Sometimes we prefer 2/3 over 6 over 9 just because these are smaller numbers. Now we can ask, when do we stop? Well, right now you can see 2, 3. There are no common factors. So if we rewrite 6 over 9 as 2/3 by cancelling the common factor of 3, then we say the fraction 6/9 is now reduced to 2/3, which is in fact in its lowest terms, because I don't see any more common factors between 2 and 3 other than 1, but it's not a factor to cancel. So sometimes we ask students to when they have fractions as simple as 6/9, where it's kind of bugging you already that, well, 3 is a common factor. When you right away see the common factor, it's good to be able to cancel it. But there's no mathematical rule that says every fraction must be written in its simplest form. There's nothing. This is just a matter of convenience, a preference, and for fractions with small numbers like 6, 9, where you see right away a common factor, it's good to reduce it. So let's look at number 2. 100 over 1000. Now here the numbers are not small like 6 and 9. They're big, and even so, because of these zeros, we do see a common factor between the numerator and denominator pretty much right away. Why is that? We recognize the denominator as 10 times 100. So 100 is a common factor of numerator and denominator. When we cancel it, we get 1 over 10. Where do I get this 1 from? From viewing 100 as 1 times 100. That's where. So apply the cancellation law, then 100 over 1000 is same as 1 over 10. So do you see why one might prefer 1 over 10 over 100 over 1000? Not because it's more correct. They're both equally correct. 100 copies of 1000 is the same point as 1 copy as 1/10. They're both the same point. So it's not like this fraction is more correct than this. It's just this is more convenient. It looks a little better. But we don't want to go overboard with reducing fraction to its lowest term. Look at this fraction. A big number in the numerator, a big number in the denominator. Try all your small numbers to see if there's a common factor. None of those 3, 4, 5, 6, you can go through all of them, or only few of them if you know how to recognize something is not a common factor. You will have a very difficult time. I specifically chose 37 as a common factor between those two, and it's very unlikely you would have right away guessed that. So in a situation like this, my suggestion is leave it as is. Don't worry about reducing it to its lowest terms when you can't right away recognize what the common factor is. But when you're dealing with smaller numbers such as 6 over 9, I think it would, and you recognize a common factor because you know your multiplication tables quite well, then my suggestion is go ahead, apply the cancellation law, and pick this one, which just looks a little nicer for, just for aesthetic reasons. That's really all it is. Or even if you have some big numbers and you recognize some factors of 10, 100, go ahead and cancel it and arrive at this. But don't obsess over reducing fractions. Thank you.